What's good, everybody? Professor Peters here today. In my video today, we're going to be talking about a word problem dealing with area and radicals. So what you guys have to know when we start this video off is that it's really checking your foundations. And you guys know this stuff. So the problem says the side length of a square measures 2 plus 8 radical 3 inches. What is the area? So what I would say is let's start off by drawing a diagram, right? So we're going to draw our square. And one of the basic things that we know about squares is that all four sides have the same length. So if they tell us that the length is 2 plus 8 radical 3, that means we could assume that the width is also 2 plus 8 radical 3. So now, what exactly is area? Area is multiplication. So they're asking us to multiply the length and the width, and we should know that the length or the width are the same because it's a square. So let's go through now and let's see if we could actually multiply. And like you guys have seen in my previous videos, I love to use the box method. So let's go over here and let's draw out our box method. All right, so we have 2 and then 8 radical 3 up top. And then we have, let's switch colors so that this could just stick out a little bit more. All right. And then on the side, we also have 2 and 8 radical 3. So like we know, guys, we have to FOIL. So we have to multiply first 2 by both terms. And then we're going to go by and multiply 8 radical 3 by both terms. And once we do, this is what we should get. We should get 4, 16 radical 3, 16 radical 3, and then we're going to get 64 radical 9. So after going through, guys, and multiplying, right, we distributed. Now we're going to try to clean this problem up by combining our like terms. So we know that we have like terms right here, right? So far we have 4 plus 16 radical 3 plus 16 radical 3 plus 64 radical 9. And the very big thing for us to understand and know, right, is that we do not have to break down these two radicals for us to add. So once we add these two, all right, we're going to switch back to black. We're going to have 4 plus 32 radical 3. But at the end right here, guys, if we pay attention, we know that this is a perfect square. And what that means is we're going to have to simplify. And once we simplify, this is going to turn into 64 times 3. And let's grab the calculator real quick, right? Always double check. I believe it's 192, but let's just make sure. Yeah. So plus 192. Now, typically at this problem, we're going to think that we're done, but for us to finish the area, we're going to have to also combine these two like terms. So our final answer would be 196 plus 32 radical 3. And before we wrap this problem up, just please remember this, guys, right? Our units were inches, right? So if we do inches times inches, we know we should get inches squared, or we could say square inches. All right, so please make sure that you guys remember that. So when we wrap this problem on up, we should just make sure that we put inches squared at the end, and this would be our final answer. But before we wrap the video up, we're going to do one more problem. And this problem, we're going to work backwards. So let's erase the board and let's go back and let's see if we could also figure out how to solve this second problem. All right. So in our second problem, it's a little bit different now. So what they're going to do is they're going to give us the area, and now they want us to figure out what is the missing side length. So let's write this down. All right. So we have the area All right, guys. So, second problem says the area of a rectangle is 2 radical 15 feet squared. If the length of the rectangle is radical 6 feet, what is the width? So, previous to the last problem, what I'm going to do is I'm going to start off by drawing a Venn diagram so we can get a better representation of this, right? So, we have a rectangle now, all right? So, that means that opposite sides are equal. So we know that once we multiply, we're going to get 2 radical 15 square feet. And we know that the length is radical 6. So how exactly are we going to solve this problem? So let's think about the formula, right? Area is equal to length times width. We know the area, we know the length, we're trying to find width. So what does that mean, right? That means if we want to figure out what W is, we're going to have to take the area and divide it by the length to find W. So what we did here was just rearrange the equation so that we know to solve for W, we got to divide area by our length. So let's go through now. Let's set this problem up. And remember, guys, if you forgot how to do this, please check out our rationalized denominators video because this is exactly how you do this, right? So we start off our problem. 2 radical 15 over radical 6. We all know that, hey, cannot have radicals in the denominator. So what we need to do is rationalize it, get rid of it. So I'm going to multiply by radical 6. Right? So this is our first step as we're getting to rationalize. So now we're going to have 2 radical, let's see, I believe this is 90, all over radical 36. So let's just focus right here, guys, because we're going to clean this problem up. So what we need to do is understand that we're going to break both of these radicals down. So we know that 36 is just 6, right? That's a perfect square. So let's put our 6 there. And then on top, we're going to put 2 times, and we'll break our radical down as radical 9 times radical 10, right? And remember, we're trying to simplify this as much as we can until we cannot simplify anymore. So at this step right here, we notice that this is the only perfect square, and this is going to turn into 3. So what happens now is we have 2 times the square root of 9, which is 3, times radical 10 all over 6. And if we notice right here, right, I'll bring it right here so it's in front of you guys, we're going to have 6 radical 10 all over 6. And if you guys remember fractions, right, remember you guys know all this stuff just about foundations. How well do you remember it? If we remember fractions, we could simplify, and our final answer should just be radical 10 feet for the width. So when we're talking about radicals, guys, and we're talking about area, remember all the same rules, foundations apply, all right? If we talking about area, that's length times width, right? And when we're working with our radicals, we know we only can multiply them if they have the same root. Hopefully this video was helpful for you guys. This is Professor Peters. Hope you guys like our new video format for all our upcoming videos. Please join us on Wednesdays 2023, every Wednesday, 6:30 p.m. We're going to have our live sessions. Thank you guys so much for joining me today.